You might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. This is why the area boasts powerful geysers and hot springs, but it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah discovered that this chamber was much larger than previously thought. They even found another reservoir with magma beneath the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the two reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. The most concerning aspect of the magma chambers is that they tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. Additionally, Yellowstone is considered an active volcano, with a volcanic explosivity index, yes, there is 1 of 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put this into perspective, the eruption of Mount Pinatubo in the Philippines in 1991, considered the most powerful in living memory, was given a mere 6 on the Volcanic Explosivity Index. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. This sounds like a lot, but keep in mind that the most impressive event of the month was a mini-earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29 and continued until the end of the month. Yes, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is indeed more active than usual, but it's nothing serious. A geophysicist working at Yellowstone Volcano Observatory, Michael Poland, claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface, and there should also be enough pressure to cause this magma to rise. However, neither of these conditions exists today. According to Poland, Yellowstone is stable for now. At the same time, Poland and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of these signs can include the frequency of earthquakes and ground deformation. Thousands of mini-earthquakes coupled with extreme changes in the surface of the ground in that area can be alarming. The team also monitors the temperature of the park's thermal features, which is another noteworthy sign of a potential disaster. Park-wide changes in geyser activity, as well as gas and thermal emissions, are also being observed. Despite media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that one of the most popular misconceptions about volcanoes is that they don't follow timelines. If a super eruption did happen, though, the most worrying thing for us would not be the lava flows or the earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a super eruption would be the ash fallout. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 super eruptions in the history of the volcano, the most powerful of which was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent super eruption, it was dubbed the Lava Creek eruption. This eruption formed the Yellowstone caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown super eruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Let's delve into what was happening all those millions of years ago, though, because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding as more and more magma arrived over time. The land over the volcanic system was rising upward almost unnoticeably. A year before the super eruption, Yellowstone gave a warning, a burp perhaps, but that long ago, there was no one who could interpret these signals. Moreover, those alarming processes were mostly occurring underground. For instance, decompression releases gas bubbles, which can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up, creating a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after shaking it, something like that was happening near the volcano, and think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted, geothermal pools and geysers heated up to boiling temperatures, and the water became more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe, but the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash curled up into the air. Within several minutes, a pyroclastic flow rushed across the area at hurricane force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot expanding gases. It looked like an extremely hot, toxic snow avalanche with a temperature of about 1,300 degrees. It was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sun blocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing super eruption, was colossal, as researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. If such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coasts, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops, contaminate pastures, and ruin power lines and electrical transformers. So I'm sure you'll agree with me that it's a good thing such a disaster isn't expected to occur anytime soon. Hey, we've got enough other stuff on our plate. The ground shakes beneath you, the pictures rattle on the walls, you hear a rumble off in the distance, then boom. A deafening explosion, the shock wave blasts through the windows, setting off car alarms. You duck under the dining table for cover, but then you remember you live not far from a supervolcano in the middle of a tropical jungle, so staying in one place isn't a good idea. The shaking finally halts. You take this chance to peek outside and see a giant cloud of smoke covering the sky. It's lunchtime, but you wouldn't know it. The sun is completely veiled, and darkness blankets the city. The power is out, and in this eerie darkness, you see red molten lava shooting from the sky and spilling over the rim of the volcano. You run outside along with dozens of your neighbors. Your priority right now is to find safe shelter, and fast. You think about taking the car, but with everyone running on the road, that's a no-go, so you run on foot where the crowd is heading. Supervolcanoes are in a league of their own when it comes to natural disasters. Surprisingly, it's not all about size or height. A volcano is dubbed super if it erupts more than 240 cubic miles of magma. That's more than enough to overfill Lake Erie. It must also have a history of erupting with a magnitude of 8 on the Volcanic Explosivity Index. The largest active volcano on Earth is Hawaii's Mauna Loa. It's so big it would cover the entire state of Rhode Island, plus some. Next time you see a commercial plane flying high in the sky, remember that the 30,000-some foot altitude is about as tall as Mauna Loa is from base to summit. It's technically taller than Everest when you measure it like that, yet it's not considered a supervolcano. As you're running along the dark road, not knowing and barely seeing where to go, a massive flaming boulder suddenly smashes through the bridge in front of you. You and everyone else are now stranded on the side of the volcano as it gets more chaotic each second. Most of the crowd disperses, finding their own ways to safety. You remember there's a way to the other side that not many people know about, but you'll have to cross a raging river through the dense jungle. You calm what's left of the crowd, and everyone follows you to your secret getaway. You finally get out of the city limits and head into the jungle. With the sky already dark, the tall trees and thick leaves make it almost pitch black. Everyone gets out their phone flashlights to navigate through the dark path. You all need to stick together and make sure nobody gets lost. Suddenly, fiery rocks strike the trees not far from you. Everyone jolts and tries to rush ahead, but nowhere is safe when it's raining scalding fire all around you. You and your group have to pick up the pace, or else. Imagine a typical avalanche or mudslide are very dangerous situations on their own. Now imagine an avalanche of lava rocks and molten lava sliding down a mountain instead of mud. That's what's making its way toward you right now. More and more people catch up with your group and bring news that the entire neighborhood is submerged in lava. It's traveling quicker than you thought. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope is. Lava can flow slowly, at about 20 feet a minute, a fraction of the average person's walking speed, or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous problem. If you didn't have protection, the gases spewing from the eruption would fill your lungs, and those spread faster and further than the lava flow. Your eyes and throat would be itchy, you get a headache, dizziness, an increased heart rate, and difficulty breathing. The worst would be passing out from the lack of oxygen. Luckily, everyone managed to grab their gas masks before leaving their homes. You're now entering the treacherous terrain of the jungle and the danger zone. Everyone's phone batteries are giving out one by one, so your vision is even more limited. The terrain is tougher, and you can't hear any sounds from the river. At this point, you're not even sure if you're going the right way, but your instincts tell you the deeper you go, the safer you'll be. The path is muddy, and the vines are hindering everyone's movements. That's when you hear something big running through the jungle. It's coming up on you fast. You can't see a thing until it's right up on you, a bear. And there goes a rhino. Wild cats, domestic cats, dogs, different creatures of all sizes and species, they all come running through the jungle right past you. You and your fellow humans aren't the only ones fleeing from the eruption. The rumbling is still going on. Before you know it, a shower of fiery rocks strikes right behind you and ignites parts of the jungle. There's no going back. Everyone picks up and runs for it. You hear thunder in the distance. A flash of lightning lights up the dark sky. You think, finally, some rain to wash away this fiery nightmare. But that's not a regular storm brewing. These giant smoke clouds can mimic a thunderstorm under similar conditions. Your luck finally pays off. You hear the river straight ahead. You reach the bank and have to hop on some stones to get to the other side. You almost slip when someone from the group catches you just in time. That was too close. Not far down the river is a large waterfall leading straight to a shallow lake with sharp rocks at the bottom. The ash from the lava falls like snow, covering most of the trees and landing on the river. Ash is one of the most dangerous things about volcanic eruptions. You're soaked to the bone, but it's a lot better than ash and smoke. The rest of the group follows. The next thing you know, the river starts steaming as lava meets the bank and runs into the water. You try your best to speed things up. The lava can heat this water to dangerous levels, and there are still people slowly crossing the river on the slippery rocks. Luckily, you manage to get everyone across, well, almost everyone. You turn around and see someone's leg caught between two rocks. The lava continues to pour into the river, and you can feel the heat of the steam. You rush back to this person and try to pull them out, but their leg won't budge. Someone else from the group comes to help, and you're finally able to pull them out in the nick of time. You and everyone else, now exhausted from your trek, keep going as far as possible. That's when you see the main road that connects you to the broken bridge. There are others on the road that got out safely, and even some cars filling up with survivors and heading fast out of the area. The volcano is still spewing lava, and the entire city is flooded with it. What was once your town now looks like a giant burning lake. Planes and helicopters can't fly because of the smoke and ash, so don't count on an air rescue. You're still at risk, even though you're on safer ground, so it's still too early to celebrate. Everyone continues to move away from the city, the further, the better. The ground continues to shake, but this time it's even more intense than before. Supervolcanoes are powerful enough to cause many earthquakes, but it's a good thing you're out in the open, far from the buildings and debris in the city. Now, back to reality. Rest assured that a volcanic eruption of this intensity won't happen for a very long time, as in millions of years. Besides, thanks to warning systems and humanity's preparation for such an event, it's extremely rare for even a regular volcano to do as much damage as it could. So don't scratch Yellowstone off your travel list just yet. When we think of active volcanoes, one region comes to mind, the Ring of Fire in the Pacific Ocean. 3/4 of Earth's volcanoes sit within this belt. Compare the area to Australia, which doesn't have any volcanic activity. The old continent of Europe is also calm, or at least we like to think so. Can you guess what the most active volcano in Europe is? If you thought of Mount Etna on the island of Sicily in Italy, you were right. The volcano has erupted about 200 times and has been far from sleeping in recent decades. The last time this happened was in August 2023. The highest mountain in the Mediterranean is 500,000 years old, but in Iceland, there is a much younger volcano. It sprang into action on July 10, 2023. In the afternoon, 3 fissures appeared in the ground on a peninsula in the southwest of the island. This was at the base of a small mountain. Its name means Little Ram in the local language. The volcano spewed molten lava high into the air. There were also gas plumes in the area, but the scientific community wasn't surprised by the event. They already knew about the volcanic area that stretches between the cities of Reykjavik and Grindavik. Its name is hard to pronounce. Hey, I want to buy a vowel. It had already erupted during the previous 2 summers. This activity came after 8 centuries of dormancy. In the days leading up to the latest eruption, seismologists, the scientists who study earthquakes, recorded over 12,000 tremors. When the ground opened up in July, the fissures were over 1.5 miles long. The following morning, 2 of them closed. All the lava was now coming out of the last fissure. It grew into an elongated cone, the simpler shape of a volcano we are all familiar with. The lava soon filled a large crater. It grew almost 100 feet tall during the first week, and it is still growing. On the night when the eruption started, lava spread out in all directions. Its cinders set ablaze the dry moss in the vicinity. Local authorities closed off the surrounding area as there were toxic gases from the volcano and smoke from the burning moss. Firefighters flocked to the area, and after a week, they proclaimed the area safe. Visitors soon came to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. People come from all over the world to watch active volcanoes. The land of fire and ice is home to more than 130 volcanoes, some 30 of them active. Now I know what you're thinking, is volcano tourism safe in Iceland? It is. The country's authorities research and constantly monitor all of the hotspots. The island is dotted with several dozen seismic stations. These help researchers accurately predict future eruptions. Emergency services are accustomed to these sorts of events and can quickly cordon off danger zones. This is what happened in 2010 when a volcano in the south of the island, the name of which everyone struggled to pronounce, erupted. It spewed out a plume of steam and ash that was 7 meters high. This wasn't a fun time to be an air traveler. Winds carried the enormous plume southeast toward northern Europe, causing many countries to close their airspace for several days for safety reasons. The volcano erupted in March, but the Earth had been shaking from January of the same year, so seismologists knew an eruption was approaching. When it comes to the continent's youngest volcano, the tourist infrastructure is already in place. Visitors can leave their cars at a designated parking lot and then embark on a 5-hour-long trek that leads to a viewing deck. Tourists are so close to the epicenter that they can feel the heat haze from the crater. The site is most impressive at night time, and safety is never a concern. Scientists regularly chart out hazard maps that outline the borders of lava fields, so visitors who stick to the rules are never in harm's way. More than a week after the eruption started, a section of the crater collapsed, and lava flowed downhill west of the volcano. This majestic, smoldering hot river is slow-moving lava. Scientists categorize it as AA-type lava, a Hawaiian term that describes basaltic lava with a rough and brittle surface. The flow is composed of broken lava blocks called clinkers, which fall off as the substance flows, revealing red-hot areas. The cooler sections of lava are gray and black in color. As it moves forward, it produces a distinctive sound like shattering glass. Nearly a month after the eruption of the new volcano, we got aerial footage of an interesting phenomenon. A tornado formed directly over the lava flow. This occurs due to the high temperatures in the area. When conditions are right, a column of heated air can easily turn into a mini tornado. Scientists observed a similar event during the 2018 eruption of Mount Kilauea in Hawaii. The lava fields of Europe's second-largest island tell the story of the creation of Iceland. It sits above the place where the North American and Eurasian plates meet each other. Tectonic plates are huge rocky chunks of Earth's outer layer. There are roughly 20 of them, and they rest on a partially molten layer of rock. All the lava we see on the surface starts its journey here. You could say that these plates float on molten rock. Their boundaries are unstable, so when two plates grind past each other, they release tremendous amounts of energy, and the formation of volcanoes is one result. These are places where the molten rock travels upward to the surface. Iceland began to form around 60 million years ago. The tectonic plates under the ocean drifted apart enough that lava piled up on the surface to create solid ground. This ancient rock is under the waves today. As new lava reaches the surface and cools down, it pushes the old rock away from the center of the island. That's why the oldest parts of Iceland aren't 60 but only 16 million years old. The country's active lava fields are young in geological terms, with some of them being under 1,000 years old. Scientists consider the island a hotspot for volcanoes, pun intended. Nearly a third of the basaltic lava that reaches the Earth's surface in recorded history came from Icelandic eruptions. Fissure swarms, like the ones before the 2023 eruption, cover 30% of the Nordic country. For this reason, only a quarter of the island is inhabited. Norse Vikings were the first people to settle in Iceland at the beginning of the 10th century. Nature threw them a loud welcoming party. Just a few years after their arrival, they witnessed one of the greatest volcanic eruptions in history. Vikings came from a region without volcanoes, so they had no clue as to what was going on. Today, Icelanders are used to such events, which is good because their homeland is entering a new era of volcanic activity. Volcanologists suspect that recent events are an introduction to decades of more frequent eruptions. The peninsula that is home to Earth's youngest volcano is just 17 miles southwest of Iceland's capital city. It's been dormant for a long time, but present-day eruptions there are a reminder that the natural processes that created Iceland are still ongoing. Recently, scientists discovered that there is a historical link between volcanic eruptions in the north of Europe and glacier. Our planet went through at least 5 major ice ages, which were exceptionally lengthy periods when the average temperature on Earth dropped. The result was the expansion of ice sheets across northern Europe and North America. The last ice age ended about 10,000 years ago. Researchers are still trying to fully understand how these glacial periods affected volcanic activity. They suspect that the sheer weight of all that ice disrupts the flow of magma underground. When glaciers retreat, the pressure is lifted, which makes it easier for lava to flow upward to the surface where it bursts. You look up and see a bright orange flash in the sky. A bit later, you hear a boom so loud that the window panes around you burst into pieces. Then you see it, a giant piece of space rock burning high above your head, heading for Earth. When it touches the surface, the explosion leaves behind an enormous crater. It's 12 meters deep and as wide as Lake Michigan. After that, 3/4 of all living organisms on our planet are on the edge of survival. This event took place about 66 million years ago, and the bright flash in the sky was the very asteroid that wiped out the dinosaurs. These days, people have many ways to protect themselves. For example, we could hide in bunkers deep underground. Such bunkers would already come in handy since there are many asteroids in the sky, and some of them are just waiting for their ticket to Earth to wreak havoc. For example, the asteroid 1990 MU will come alarmingly close to our planet in 2027. Many people fear that Earth's gravitational pull will trap this rock, which is the size of 2 Brooklyn bridges. If this happens, it will start to move closer and eventually crash into the planet's surface. Such an impact would cause a shock wave that would be felt on other continents. Once the asteroid hit the ground, there would be an explosion so bright that people would think a new sun appeared right here on Earth. The collision would release a huge amount of energy, which would then turn into heat. Everything around the impact site would catch fire, and if the asteroid fell in the water, it would cause tsunami waves higher than the Empire State Building. Many coastal cities would be flooded. The dust that would rise after the explosion would cover the sun, plunging the world into darkness. If the dust stayed in the air long enough, the climate on the planet would change, and Earth would start to freeze. If you think such a small meteorite can't cause serious damage, look at the Chelyabinsk meteor. It hit Earth in the winter of 2013. When the space rock entered the atmosphere, people miles away heard a loud bang. The brightly burning object was approaching the surface at about 11 meters per second. Halfway through its flight, it split into several pieces, causing several stronger shock waves. When the meteorites hit the ground, they caused a major earthquake, and the aftershocks from the explosion shattered the windows of 5,000 buildings. People in 6 cities around the crash site felt the aftereffects of the fall, and this meteorite was only 60 feet wide. Fortunately, the asteroid 1990 MU will move past our planet, so we'll be safe. But the next asteroid to approach Earth is going to be 3 miles wide. It's called 3122 Florence. If this giant hit our planet, it could wipe entire continents off the face of the Earth. In 2017, this space rock got awfully close to us. It could be seen in the sky even with a small telescope. Now, the next asteroid is the biggest one to worry about, 1999 JM8. It's about as wide as Manhattan and has an unnerving habit of approaching Earth a bit too close for everyone's liking. A small asteroid named 2020 VT got closer to our planet than all others have ever done in November 2020. It flew over the Pacific Ocean at an altitude a bit smaller than the distance from Los Angeles to Las Vegas. That space rock was about the size of a big car. If it did make it to Earth's atmosphere, it would burn up completely before touching the ground. Falling asteroids and meteorites aren't uncommon on our planet. Luckily, most of them burst into flames and burn up before they enter the atmosphere. Mars is to blame for such frequent meteor showers. The planet isn't far from the main asteroid belt in the solar system. Sometimes, the gravitational pull of the red planet grabs asteroids from there, then, Mars spins them around and flings them in our direction, just like a slingshot. So, Mars is a bullet H. It's a good thing we're protected by Jupiter. It's the largest planet in our solar system and has an incredibly strong gravitational field. It keeps the asteroid belt in line and protects us from being constantly hit by a rain of meteorites. And that's good news, considering Ceres is in the asteroid belt. This enormous space rock is so big that it was once considered to be a planet. Then, for many years, scientists called Ceres an asteroid, but in 2006 it was finally classified as a dwarf planet. This space object contains a third of the total mass of the asteroid belt, which is about 4% of the Moon's mass. If Earth were as large as a nickel, Ceres would be about the size of a poppy seed. So, what if an asteroid several miles across was heading toward our planet and people had to stop it? Well, we could break the space.